Everybody, happy Tuesday or whatever day you're watching this. Hopefully it's Tuesday. Harrison, welcome back. Anyway, so Miss Street is going to pass you out a lot of different things today. It is really, really important. I know it's a shortened period that we transition really well. So don't mess around when she says put things back, pick up things, etc., etc. All right. So in front of you on the screen is an Exploragon all put together. That is what the manipulative you're going to be working with today. Now, the one thing I did want to tell you is that when you put an Explorer together, you have to connect the ends because this blue Exploragon is a specific length. So it's not like you could connect this yellow part over here, even though you can like physically connect it to that one. You could only connect end to end when creating triangles because you have to preserve the actual lengths of them. So would be the correct way that you would attach the purple, yellow, and light blue Exploragon to create a triangle. All right, so just keep that in mind as you're going through these activities. So first thing is first, with a partner, if you turn to page 25 and 26, you will see a list of 6 vocabulary words. Those vocabulary words are the ways that we classify triangles. Your job, and it has to be with a partner because I don't think we have enough Exploragons for everyone to do this on their own. You can either do groups of 2, groups of 3. Your job right now is, and you're going to pause the video when I'm done explaining this, is you are going to create 6 triangles on your desk. The triangles have to be an acute triangle, a right triangle, and obtuse triangle. And then also you are going to create 3 other triangles, one was which equilateral, scalene, and isosceles. Now remember, acute means that every one of the angles in there has to be less than 90. A right triangle obviously is where one angle is 90. You're not going to have 2, which has to be 1. An obtuse triangle, there's going to be 2 acute angles, but there's going to be one angle that is greater than 90 degrees. And then for equilateral, all sides are equal. Scalene, you're going to have a triangle where none of the sides are equal. And isosceles, there's going to be 2 equal sides. So pause the video. When you're done, we're going to just share out which colors created which ones, and we're just going to double check that. All right. So hopefully you got a chance to do that. I will tell Miss Street to only spend about like 5 minutes on this, but hopefully you guys were able to create these 6 triangles. You don't obviously have to memorize the colors that you used, but it's important to know that these are the 6 ways that we can classify triangles. So next, I want you to create, basically take the Exploragons, and I want you to find 3 colored sides, and you could have like 2 of the same color if you want, but basically 3 Exploragons. And I want you to find one that if you try to connect them, it will not create a triangle. Again, I repeat, if you connect the ends, it will not fully connect to form a triangle. Okay, so the sides won't connect. However you move them, let's give everyone about like 2-3 minutes to do this. And what I want you to do is write down the side lengths. If you look closely at the Exploragons, they have the actual numbers, like the actual what the lengths are. I believe it's centimeters. Pretty sure it's centimeters, but whatever it is, you can just say units. And then we're going to share them whole class and see if we notice anything. So go ahead and pause and see if you can find 3 Exploragons that do not form a triangle. So hopefully you guys did that. What I want Miss Street to do right now is just kind of on the whiteboard or on this. Actually, I guess you can't use this board. What did you notice? Give us the sides that didn't form triangles. Okay, we'll take about 3 or 4 examples. And what do you guys notice about the sides for the Exploragons that did not form a triangle? Well, go ahead and pause that, answer that question, and then we're going to go through. I'm going to tell you what you should have said because I'm not there. You should have noticed what is called the triangle inequality theorem. Now, this is one of those theorems that you have to memorize the name and just kind of know what it means. But when you had 2 sides of the triangle, the 2 smaller sides, if they're not, when you add them together, if they're not greater than the biggest side, it won't form a triangle. So the way that we can say that in math speak is the 2 smaller sides of the triangle must have a sum greater than the largest side. So here's an example where 3 plus 4 is not, so I'm not going to say is not greater than 10. Can't be equal to 10. So if it was equal to 10, if you had like 6 and 4, it would form an exact straight line. But as soon as you try to move it up to form 3 sides, it wouldn't work. So it can't be equal. So if you had sides 4 and 4 and 8, this would not form a triangle because, again, the 2 smaller sides have to be, when you add them up, have to be greater than the largest or the third side, the largest side. And that is the triangle inequality theorem. So what I want you to do right now is here are, I want you to go thumbs up, thumbs down. Will these, and Miss Street, you can just pause the video as people go through each one. So I'm just going to say pause the video. After each one, pause the video, have everyone do thumbs up, thumbs down, and then I'll tell you if you're right. So does this one form, would that one form a triangle? The answer would be no, because 6 plus 10 is not greater than 19. Would this one form a triangle? The answer is yes. Oh, I'm sorry. Whoa, sorry, my bad. The answer is actually no. I tried to trick you guys and I got mixed up in my own trick. So just because they're ordered like this, the 2 smaller sides are 2 and 5. And 2 plus 5 is not greater than 8. So that would not form a triangle. The third one would form a triangle. The fourth one would form a triangle. Now, a lot of people say, well, which one's this? It doesn't matter. Just pick they're all the same size. So any 2 sides, you would always be greater than the third side. There's really no smaller sides or larger sides there, but that works. And this one would be a triangle. 1 plus 1 is greater than 1.9 or 1 and 9/10. And the last one would not form a triangle. Okay. And that's how you use the triangle sum theorem to know when 3 sides will or will not form a triangle. Okay, moving on. Oops, sorry. All right. So here's a quick, after we go over this, I want this to be about a 3 or 4 minute, just quick challenge problem. So if 2 sides of a triangle are 10 and 18, and you have to think of a third side that will form a triangle, like for example, you can't pick a side of 200 because 10 plus 18 is not greater than 200. But you have to think of a range. So basically saying 1 to 4 units or whatever, a range meaning what's the lowest to minimum to maximum the third side could be. What would the range of the third side be? So go ahead and pause the video and let's try this one. All right. So what you should have done, so you could have kind of done this logically. I like to make inequality statements. So the third side, it could either be the largest side or this, I'm thinking about it being the smallest side. So if it's the smallest side, let's say x was the smallest side, that would mean that if you add that to 10, it has to be greater than 18. Okay. So using just one, solving inequalities, I'm going to subtract 10 from both sides. And that would mean that x would actually have to be greater than 8. So it couldn't be 8, but it has to be greater than 8. Then I think about, well, what if x was the largest side? Well, if the x was the largest side, then 10 plus 18 would have to be greater than x. Okay, you couldn't have x where the 10 plus 18 wasn't. So that would mean 28 is greater than x. And if I flip that around, that would mean x is less than 28. Okay, it being the middle side doesn't really matter because it'll end up by, if it's between those two, it could be the middle side. You're just thinking about what's the minimum and what's the maximum. So if I know that x has to be greater than 8 but less than 28, to write that, just a reminder from algebra last year, to write that, you'd write 8 is less than x, which is less than 28. This is a fancy way of saying that x is between 8 and 28, but notice it can't be 8 and can't be 28. And that would be your range of the third side. Moving on. All right. Sorry about that. Moving this all around. All right. So next thing, we're going to go back to our exploragons. Half the room's going to take, so basically there's just not enough for everyone to take the same. So I need someone to find 3 exploragons that we already know, because we already did it, form a triangle. And I want half the room to everyone take those 3 same exploragons. And the other half of the room, I want you to take a different 3, but it has to be able to form a triangle, okay? And what I want everyone to do, without showing everyone how they're connecting it, I don't want you to worry about the angles, and I don't care how you connect it, but I just want everyone to connect the 3 sides in any way that you want, okay? Don't show anyone yet, but go ahead and do that, okay? pause the video for about a minute while everyone does that, or till everyone gets one. So, what did we notice? Now, we never told everyone how to put them together. They were just 3 random sides, and you could have used any angles you want and just put them together. But they had to, obviously, you had to use the 3 sides, so you had to connect end to end. Now, hold them up, and what do you notice about everyone's? At least your side of the room that used the same Exploragons. Okay? What you should be looking around and noticing right now is everyone had the same exact triangle. Well, at least half the room did, and the other half did, if you're using the same 3 sides. Now, that's kind of important because no one told you how to put them together, and you might be saying right now, well, wait a minute, there was, Mr. Katz, there was only one way you could put them together. That's kind of the point, okay? There's only one triangle, and I'm just going to use sides 7, 8, and 10, for example. I know that might not have been the Exploragons that you picked, but there's only one triangle that exists. If I gave you sides 7, 8, and 10, and I told you to make a triangle, everyone's triangle would be exactly the same. This is called a unique triangle, meaning there's only one triangle that exists. The angles that you have in this triangle, everyone's angles would be the same, even though we didn't tell you what angles to make. That's because there's a unique triangle. There's only one triangle that exists. So this is the main point that we're getting at today. Having the exact 3 sides will automatically produce a unique triangle. And therefore, here's the big point. We know for sure that the triangle, I should have wrote an S there, triangles are congruent. Okay? Let me kind of just summarize this with a little bit of a picture. And we're going to talk a lot more about this tomorrow. But here's the big deal. If I gave you a triangle ABC and triangle XYZ, you're going to notice, for example, that there's 2 tick marks here and 2 tick marks here. That means those sides are the same. 1 tick mark and 1 tick mark means we know that AB, side AB, and side, XY are exactly the same. And last, this is 3 and this is 3. It doesn't mean it's 3 units. It doesn't mean it's 3 centimeters. It just means they have the same tick marks. It means they're the same. Well, what do we know about these triangles? Now, I didn't tell you anything about the angles. To be congruent means you have to have the same exact sides and the same exact angles. Even though I didn't tell you anything about the angles, I know for sure that triangle ABC is congruent to triangle XYZ. Notice I had to write it the angle X and angle A are the corresponding parts because that's the one between I'm matching up the exact same angles and the exact same sides. We know that those triangles are congruent because we know that there were 3 sides here that were used here, and we know that having 3 of the exact same sides produces a unique triangle. So there's only one triangle you can have. So even though we didn't tell you anything about angle A and angle X, I know that angle A is congruent to angle X because those triangles are congruent, meaning everything about them is the same. So having 3 sides of a triangle and just knowing that the 3 sides are equal to another 3 sides of a different triangle, you know that those triangles are congruent. And we're going to talk about this more tomorrow, but this is called, get ready, the first postulate, the SSS postulate. Now, the SSS postulate stands for side, side, side postulate. It means having 3 sides of any triangle produce a unique triangle, meaning if you know that there's 3 sides of one triangle congruent to 3 sides of another triangle, then you know that those triangles are congruent. SSS postulate tells you when triangles are congruent. All right? Have a great day. This will be posted, and please look on the floor. If you see an Exploragon, please put it back, okay? Can't afford any more Exploragons. Please do me a favor. Harrison, I'm looking at you. Please put it back. Take it out of your pocket, Harrison. Harrison. I'm just kidding. It's definitely Francis. Francis is definitely taking him. All right, bye-bye.